and she is a data engineer working at Linkit. Good luck, Dana.
Thank you. So thank you for the organizers, and thank you for everyone for joining this late and for choosing my track. I know there are many awesome tracks going on right now at the same time, so thank you for joining this one, and I hope it will be very informative for you. So this webinar was initially intended as a workshop with Python Amsterdam, and it was meant to be a bit longer, so around 2 hours. So I just compressed it a bit into a live demo and like a short introduction about serverless. If you don't know about PyLadies, that's a meetup group in Amsterdam, and they organize awesome workshops. They provide mentorship, and also they welcome Python users from different levels. So you can definitely join if you want. So today I'm gonna talk about, so this is, first of all, this is a session intended for complete beginners. And so people who have little to no prior experience with the cloud, and maybe with some experience with Python. So you will need some basic Python knowledge to be able to follow the live coding part. And before I go on, I'm going to introduce myself quickly. So I'm Dana. I'm data engineer at Linkit. And previously, I have experience as a software engineer. I have some background in robotics before I switched to data. And now my main interest is providing solutions for data-driven companies. And I'm interested in data-intensive systems. So if you want to connect, please do. Aliona from PyLadies is already joined the comment section, so she will be there to answer any questions. If you joined via the meetup group, you probably saw that there is some prior setup. I will not cover that, and I will not cover the entire workshop, but you're more than welcome to send any questions you have later to me or to Aliona, and we'll be happy to answer them. So let's go over first about what I'm going to cover today. So as I mentioned, I'm going to explain why you should be interested in cloud computing if you're not using it already. Then I'm going to explain what is cloud computing. After, I'm going to explain what is serverless. And for this, I'm going to use a function as a service offering from Azure called Azure Functions. I'm going to explain how you can use Azure Functions in Python. And finally, I will explain how you can properly structure your Python code so you can use it in Azure Functions. And I'm going to have a demo for this so you can see how easy it is to start with Azure Functions in Python and integrate your own code with them. So as I mentioned, there might be some complete beginners and people who are not familiar. So I'm going to start with very basic introduction about why you should be interested about cloud computing. So imagine that you have an idea for some awesome application and you believe that this application will provide excellent user experience and it will generate a lot of profit for you. However, in order to be able to reach your target audience and to, make people use it and spread the word about it, you need to deploy it. So you need to find a way in which you can release it and the application needs to reach a target audience. So to deploy an application, you need, first of all, specialized knowledge, and you need appropriate developer group that will have this knowledge. But moreover, you need appropriate infrastructure. So you need servers, you need databases, you need to think about security, etc. And this in combination with all the hardware, you need to know how to set it up. So that requires a lot of specialized knowledge, and it's a lot of checkboxes you need to tick before you're able to deploy it. It's a lot of components, and it seems like we need to care more about the infrastructure instead of the application itself and the developing. And this is what we care about as developers. So we need to think if there is a way to simplify this process and only work on the code. So this is where cloud computing comes in. First of all, we need to understand why this is risky. So because we have to invest so much in advance, we need to think about how the initial setup. I'm sorry, I got a bit nervous. So as I mentioned, like we have the initial setup, like we need all the servers, we have all the hardware, we need to set up initially, and we need to think about initially how expensive this might be. So this means that if we think about the target audience, like what if you buy a big amount of servers and then you don't have the complete target audience you might have. So you made a huge investment in advance, and this might not be like you might lose a lot of money in the end. So this is risky because you might create a big team in advance and invest in a lot of servers, and in the end you might not get anything in return. So cloud computing offers an alternative to this in a way that you can provide all the infrastructure for you instead of you buying all the servers in advance. So cloud computing is a platform that provides access to computing resources over the internet. This means that you can access a lot of computing resources via the platform like Microsoft Azure. So basically, you have, I'm sorry, just a moment.
I think we're experiencing some. Jana, welcome back.
My screen is freezing and I cannot see the slides I'm going through next. So I'm just clicking, but the slides are not going, like they're not changing.
Okay.
So I'm having a bit of issues with that.
Can you restart your PowerPoint?
Presentation? Yeah.
Yeah, your app.
Just a moment. So I got, like, it's a bit difficult because I cannot follow the when I prepared at least on.
No worries.
This is live debugging the presentation, which is awesome.
So I can see it like this, but once when I enter a full screen mode, I cannot see the slides changing for me after I.
If this is very difficult for you, you can keep your screen this way as well, if that is easier for you. You can decide.
Okay.
Yeah, is that better?
Yeah, but I guess it's not as nice. I'm sorry about this.
No worries, no worries.
Okay, let's continue. Let's see if that's well this far. So as I mentioned previously, let's just recap. I think I wasn't super clear. So we have risk when we are setting up our servers initially, and like we're making the initial investments, is we cannot assume from start how much everything will cost. So we need a way to move the worry from thinking about the costs to how we can only care about the code. So this is where cloud computing comes into play. And as I mentioned previously, that's a platform that provides access to computing resources over the internet. So what does cloud computing can do for us? So first of all, it can provide us with data centers. So basically, cloud providers have a lot of data centers in various locations. And what this provides for you is basically access to servers, computing power, storage, etc. Then we have a lot of services that cloud providers provide for us. Here we have like services like storage, and we can think about like different kinds of storage. Then we have machine learning services or basically data analysis, etc. And finally, the most important thing is that the cloud computing like providers provide cost-effective way to run our applications. Basically, we only pay for what we use, which means that instead of thinking in advance and buying in advance servers and like scaling as things progress, we only pay for the services we use, and that's based on request. So you only pay for what you use, and you, in that way, it's very easily to scale and reduce your costs. So let's look at the services that cloud computing providers provide. So they offer AI and machine learning services. Then we have analytics, compute services. Here, like this is one of the services that we'll talk about later, Azure Functions. They provide containers, databases. Here we have like different kinds of databases, relational, non-relational, etc. We have migration services. So we can use a cloud provider to migrate from one database to another, different networking services, and security. So what's Azure? I think all of you are already familiar, but for the complete beginners, this is a cloud provider that offers ever-expanding set of cloud computing services. And we're going to talk mostly about that today. So now when we see what's the cloud, let's think about like why would we need serverless. So serverless is a way to run your application without caring about the infrastructure. So here, I mean that you don't have to care about basically pitching your service, installing all the security, like security dependencies, caring about your Python dependencies, and etc. So I'm not saying this is not valuable work, but instead of caring too much about like doing all of that, you can provision it, and this provides a lot of value for you as a developer, because you can focus more on the KPIs and focus more on the code you're developing instead of the infrastructure. So Azure Functions is a way you can run this kind of like serverless computing, serverless functions like in server, in the cloud online. So that's a way to run event-triggered code without having to explicitly provision or manage infrastructure. So you can think of Azure Functions as a code in combinations with events and data. So this means that you write your code and then you're waiting for certain trigger or an outside event to start it. So this is kind of a mind shift. So instead of thinking about the code as you're writing it, you think about the function you're creating, and then you have a certain event that needs to trigger it. So imagine that you have, let's say, a blob storage, and you have an image storage inside. So you are waiting for basically a new image to be uploaded, and then this will result in your function getting triggered and doing some computation. Other types of triggers can be basically sending an HTTP request, maybe a user login, or like a new row in a database, or like some kind of batch job. And after this will trigger the code to be sent to a database, or some kind of output, like we need to glue our function with another services. So basically what we can do is send the output from the functions to, like, for example, to another service like a database, or use it in some machine learning project, etc. So what we can like sum up from all of this is that Azure Functions provide a really easy way to build applications using serverless functions. And we can manage our applications instead of our infrastructure and spend more productive time as developers. So Azure Functions offer like choice of language, so we can use different kinds of languages like Python, JavaScript, etc. As I mentioned previously, they follow the pay-per-use pricing model. So you basically only pay for the time when the function is running, and you don't care about all the, like, you don't care like whether you have any hidden costs while the function is idle or not running. You can use the dependencies you use in your Python project so far. So that's like an added benefit, you don't have to restructure your code additionally. All the dependencies you're using in Python, you can easily use them in your Azure function as well, and I'm gonna show you how you can do that. It has already some integrated security, so it also saves you up some time on that side as well. It also offers a really easy integration that I showed previously with other services. So if you looked in like the previous graph when I showed the event-driven architecture, you can very easily glue different services with your Azure functions as an input and as an output. So you have a big choice of events you can use to start your function, and then you can really, really easily use that output, like the thing that the function is computing, into different service in Azure. So I don't know, load it in a database, store it into blob storage, use it for your machine learning models. Like, I don't know, a lot of different things you can do with it. It offers really flexible way of development and deployment. Part of the workshop is about deployment, so it's really easy to deploy your function in the end after you develop locally. So you can look at that as well. And finally, it's open source, so you can like look at the repository and like play with it a bit. So I'm going to talk shortly about what are the potential applications, like great applications for Azure Functions. So they're really, really good for processing data. Why? Because you can easily trigger an event that can get the data from somewhere, then do some transformation, and finally load it somewhere. It's really, really easy to glue this thing together. Then it's really nice for integrating systems. I'm going to show a bit later with the way, like, because they support nice triggers and bindings. It's good for working with IoT, creating simple APIs and microservices. So Azure Functions support, as I mentioned previously, triggers. That's the way that you start the execution. That's what tells your function that it needs to start running. And they also support bindings. So in Azure Function terms, that's a way to simplify the input and the output of the data into the function. So now let's look shortly in the types of triggers and bindings Azure Function support. As triggers, or as I mentioned previously, the way you tell the function it needs to start running, it supports, basically, it can detect events in blob storage, different HTTP requests, events in GitHub, etc. And we can glue our functions, like we can use the input and the output from different tables, I don't know, the DocumentDB, for example, other like relational databases, Q, etc. So Azure Functions were released in 2016, but they didn't have Python support until 2019. So this is a very recent development, and like really welcome one. It's like nice addition. So Azure. So I'm gonna talk about a bit now about how we can use Azure Functions in Python. Like what are the best practices? So although I'm focusing on Python, this is not only like applicable to Python. You can like apply these principles and these practices to other languages as well, because some of them are just common sense. So let's dive a bit like into that. So first of all, when you write Azure Functions, you like very like simple one, you need to have reasonable name for a function. So let's look at this one. Like it not really doesn't really tells us anything, and we need to know that the function will be used by other developers as well. So instead of saying something like get maxd from data frame, it's better to make it clear like what the function is getting, and then you can specify the like what's the input in the arguments. The function needs to have a single responsibility. So when you're using Azure Functions, you need to keep in mind that the function has only limited running time. So the default one is around 5 minutes, and it cannot run longer than that. So if you write really, really long functions, you need to be aware that like it might not be able to finish on time. So if you write a nice function, like short function that has a single responsibility, you, in the same time, you can make sure that the function will not run longer than it's supposed to. So if you look something like this, like this is not a good practice. Why? Because the function is doing more than one thing. So it's always a good thing to separate responsibility and have one function per one thing that needs to be done. So related with the previous point, the function should be very short and readable. So there are some red flags you can look at here. when you look at the function, like for the first time, you should be immediately able to determine what's the function purpose. If you're not able to do that, that probably means that there is like the function should be like shortened and be made more readable. If the function contains really deeply nested control structures, that means that like something is wrong. Like the logic should be as simple as possible, and you should try to focus on making the function like a bit more. So it shouldn't be too like it can be complex if there is a necessity, but you should always try to simplify the logic as much as possible. So you should also be very aware that the logic shouldn't be duplicated in other methods. So we should always like check whether the code like is repeated somewhere else. Also, like if your massive grade developer display is not big enough to display the function, that probably means that you're doing something wrong and you should make it shorter. The function should be idempotent. So this means that every input that you're getting, every input event you're getting, you must identify whether it was processed before or not. So let's look at a simple scenario. So we have blob storage that triggers an Azure function. And this Azure function writes after that into databases. So we need to think about this possible scenario, like what will happen if one of these two cases like fails. So what if we successfully write the first database, but we fail to write to the second database? So one easy thing to do is to just like restart the process. However, we're risking a possibility for creating a duplicate, right? What will happen if we try to write the same entry to the first database again? That means that we might like create a duplicate row. So we need a way to prevent duplicate rows from being created. So there is a way we can do that. First of all, like we need to extract a unique attribute from like the output we are generating from the Azure functions. Like think about some transaction ID. Then we can quickly check whether this attribute already exists in the control database. And then if it does, we can just terminate the execution and like stop the whole thing. And if it doesn't, we can continue the execution normally and then write the row that was missing into the database. When the function finishes successfully, we should include the record in the control database so we can protect ourselves from like future failures like this, and then finally finish the execution. As mentioned previously, the function should finish as quickly as possible because Azure functions have a time limit about how long the function can run. So if it runs longer, like the execution will be terminated. So you need to closely monitor how long your function is running. Then if you're using recursions, like you need to be careful with it because you might end up in an infinite loop. So try to either set up the depth of the recursion and monitor how long the function is running, or completely avoid recursions. Then the function should be stateless. So what does this mean? First of all, you cannot control where and when function instances are provisioned or deprovisioned. So there's no way to store data within the process between requests reliably. If you want, you can utilize external storage, but this is something you need to keep in mind. Also, like common sense, you need to include a docstring for other developers, so it's easy for them to follow what's like happening in your code base. And when you're writing a function, you should always think about writing defensive functions. This means that you should always assume that errors are going to rise. Use assertions, which means that you can like quickly check whether the code is producing like the correct input and output. Then use preconditions to check that the inputs of the function are safe to use. And finally, you should use post conditions to check that the output from a function is safe to use, meaning like you need to check whether it is safe to propagate the output to like the other services. And finally, a good practice is to write tests before you write code. In this way, you can like think in advance about the logic of the code you're trying to write, and also like test all the functionality in advice. And like finally, I don't think it's like necessary to say, but still say it from time to time. Please don't hard code secrets. There are ways you can handle this, like either with environment variables or qvault, for example. But definitely don't leave it in your code. So what do you need to consider before deciding whether you want to move your application to become like serverless? First of all, you should be aware that serverless is not right for every project, especially if you want like complete control over things. Also, like if your workloads are constant, then it's probably not a good idea to use serverless. Serverless is awesome when you have basically changing workloads. So let's say you have periods of very high activity and then followed by a period with like not so high activity. This means that you will get like really low bill for the time when the function is not running, and like it will scale automatically when you have higher workload with more users. If your workloads are constant, then probably serverless is not necessary for your project. If you have very long running functions, then no, you cannot use Azure Functions because you have a time limit, like the maximum amount of time which your function can run. And you also need to check the supported languages. For example, Python was not supported until recently, so it should be one of the ones you are familiar with, and it's also supported. Then you should structure your code following best practices, and you should optimize your code for the billing model. So you're sure that really your application will be as low cost as possible. Finally, lock everything. Like it will be really helpful for, like you will do yourself a favor. It will be really easy to figure out what went wrong once something goes wrong, and it will. So let's jump into the workshop. Let's see how we can create a simple serverless function. I'm going to quickly switch my screen to the terminal, and let's hope everything goes okay. Okay, so as I mentioned previously, so this live demo is part of the workshop I created with PyLadies Amsterdam. I'm just going to cover a part of it, and then you're more than welcome to jump to the GitHub repository, look at like the entire workshop. You can go through it, send any questions if they arise, and you're also more than welcome to contribute. So for this demo, I already created a simple project that does some basic natural language processing. But before we do that, I'm going to just show you how easy it is to create an Azure function using your terminal. I decided to use the terminal because I already found a lot of tutorials about how you can do it with, for example, Visual Studio Code or like the Azure portal itself. And I decided to do it like this just so you can easily like find a reference for it as well. So to start with this, you will need a free subscription to Azure portal. You can get it very easily. It's explained in the workshop. And like if you have any trouble, just let me know. So let's go through it. So I'm gonna create initially like a simple template for my project. Okay, as you can see now, just a moment. I'm sorry, it's not responsive. I'm going to choose the language I'm planning to use. In my case, this is Python, and it will generate a template for me. So if you got this, then you're fine. This means that the project was installed successfully. If you do ls, now we can see that the project template was created. So let's generate some boilerplate code to kickstart our Azure functions. So I'm just going to cd into the new project I created, and I'm going to create a new function. Here we can choose the template we're going to use. In this case, I'm going to use a simple HTTP trigger. And maybe like other triggers could be another like nice idea for another workshop. Now we need to specify the function name. So I'm going to call it response text processing. And we can see that the function was created successfully from the HTTP trigger template. So this means that the project and the function were installed successfully. So it's easy as this to create your first Azure function, and you can already test and see what the HTTP trigger template does. So you can start, you can first see what was generated. We can see that we got like a host file and the requirements file. So the requirements file is the file that contains all the modules or the libraries you're using in Python, and you can easily use pip to install everything and then just freeze all the requirements there. The local settings JSON file contains all the local settings. So for now, we are testing everything locally, but it's really easy to deploy the function to the Azure portal as well. And finally, we have the host JSON file, which contains like the settings for the host. So let's start the function locally. So now you can see the function running. And in the end, it will give you the IP address with the request you can use for it. So now I'm going to quickly switch to Postman so I can show you how response would look like. Okay. So now I'm in Postman, and here I have the IP address, which we saw previously in the terminal. And if we, so just a second, we need to pass parameter. In my case, this is a name. So we can do that. Oops. Super quickly. You can type your name here, and then if you do the post request, it will like return a reply for you. So okay, this is a very, very simple Azure function that just takes a name, a string, as an input parameter and returns like another string which says hello plus the name. So let's close the terminal for now, and let's look how we can use a function that you already created previously in like it's an Azure function. So as I mentioned previously, I already wrote some code, and it's stored here. So here I have a simple text processing file, and I want to basically deploy some of the functions in this file as an Azure function. So to do that, just a second. The terminal was not screened. Okay, so as I mentioned previously, because I didn't share the screen, I have a file I created. And this file contains the code that we want to deploy in our case. So you can look at the details. It contains basically some very simple natural language processing methods, and we want to deploy this. So the input of this file is a text file, and the text file gets cleaned from like all the punctuation, all like words that are too common, like and or I, and then we want to basically extract the sentiment for it. I already installed all the requirements I need for this, so I'm not going to go through that. So I, for example, use NumPy. You can really easily install it using pip install, and then you can just use pip freeze to store all the requirements in the text file. So when you deploy your Azure functions to the cloud, all the requirements will be packaged together and like installed there. So let's move the file I created to the function Python HTTP example I already created. Oops, sorry. Okay, so basically the code you want to use, it should be inside the template project you created. You can look at the structure. It's explained very well into the Azure documentation. Then you want to edit the init file that was generated for us. That's also like explained into more details into the the README file that's on the workshop on the GitHub page. So I'm going to do it quickly. So I'm going to get here, and I'm going to open the init file and edit its contents really quickly. So basically, the only change I did is I changed the input it's getting, like when it's making a post request, instead of only accepting text and like returning a text output, now I'm accepting the whole file and I'm returning the process text, the tokens it extracted, and some entities. So now we can start our function in a very similar way as we did before. So just gonna go one and start the function. So we can see it's running. So now we have a different IP address from the like we have the same IP address from the one I created previously, but like the output should be edited. I still have the same get and post methods because I didn't edit that part. So if we go back to Postman, now we should be able to see that we can input a simple data file and use like that to get an output to like the entities, the tokens, and the like edited output. So I'm gonna switch very quickly to Postman again. I cannot see it in just a moment. I'm sorry for all the technical difficulties. Okay, there it is. Okay, so we're back to Postman, and now, as you can see, I have text file as an input instead of like previously I didn't have nothing in the previous request. So we're gonna use this simple data file as an input to our like Azure function, and as an output we should see basically the text. Like this is just the input we're giving. So and some of the tokens it extracted. So it's like really easy. I can open and so I'm gonna terminate this for now. And I'm gonna go into the response text file and I'm gonna open the init.py. So as you can see, all you have to do is import the code you're using. So basically the code you created, and then you just need to edit the file that was generated for you initially and just specify what the output you want to be. So in this case, we are returning a JSON and we're returning these three things. Okay, so I finished a bit sooner than I expected. I can share the link with you. So there is one final part. The final part is like in this workshop is how you can deploy this simple application we created to like the Azure cloud. And also there is another part where you can see how you can properly, like there is some bit messy Python file, and you can see how you can properly like refactor it, like following the steps I already mentioned during the presentation. Okay, so thank you, and sorry for all the technical issues.
Okay, Dana, thank you. I do have a couple of questions for you. The first one is from Mark. He says that he has a .NET background, but he would love to try functions in Python. Are the official Azure documentation around Python, is that up to date?
Yeah, it's really good as well. I think it's really awesome and like very well prepared. For complete beginners, like if you're just starting with Python, if you're just starting with cloud computing, it might be a bit overwhelming, like with too much information. So that was the purpose of this workshop, kind of like to condense everything into one place where you can easily start. But if you have a lot of experience with .NET, I think you can really easily start with like just using Python.
Okay, and the link on the screen right now that you're showing, is that the workshop link?
Yes.
Okay, great. Okay, thank you.
Yeah. Okay, thank you.
So thank you very much, Dana, for this talk on serverless functions, Python edition. I think it's really good to get started with the workshop. It's looking good. So I'm also tempted to go ahead with that. So thank you very much. And for you all viewers, thank you very much for with us from 1 o'clock this afternoon till now. We had a lot of fun enjoying all those community talks. We really missed it to hang out together, and I think it was very much fun together. Thank you all who watched for all the interactions as well. There was a lot of questions on the chats and on Twitter. So thank you for that, and of course all speakers. Given all the interactions, it was much appreciated. It's very difficult to give a talk when nobody is in the room except your 8-year-old or your cat. So it's highly appreciated. All communities, meetups, helping putting this together. We're hoping to do this very soon again. So we hope we can count on you again at that time. And of course, thank you all hosts for today's Sjoukje for being a host. And of course, major thanks to our director, producer, and all over hero, Henk Boelman, for putting this all together. It's sometimes stressful, but the result is amazing. So this concludes our virtual Azure Community Day, the first one. Hope to see you around for the next one. And thank you. And please don't forget to subscribe to the Microsoft.Source newsletter. We will put a link in the chat window. Thank you.
Thank you. See you soon.